In this video, we're going to take a short break from Java and talk about one of the essential data structures in computer science, a hash table. So let's say we have a list of customers. Let's import this. And we set this to a new array list. Now in this list, we could have hundreds or thousands of customers that we read from a database. Now let's say we want to look for a customer with a particular email. To do that, we have to write code like this. We have to use a for each loop for each customer in customers. If customer.getEmail equals, let's say E1, then perhaps we're going to return that customer or print a message like found. Now, this algorithm you see here for finding an object in a list is not scalable because the more objects we have in this list, the longer this loop is going to take. We're going to need more comparisons. In the worst case scenario, if this customer we're looking for is at the end of the list, we have to iterate the entire list to find that customer. So in computer science, we represent the cost of this algorithm using a special notation called the big O notation. It looks like this. Big O of n, where n is the number of items in our list. So if you have, let's say, 10 items in this list, the cost of this algorithm is going to be O of 10, because in the worst case scenario, this customer we are looking for is at the end of the list. So we need 10 comparisons to find that customer. Now, what if our list has 1 million customers? Then the cost of this algorithm is going to be O of 1 million. So the cost of this algorithm increases linearly and in direct proportion with the size of the input. That is why we represent it using big O of n. Now, this is where hash tables come to the rescue. A hash table is a special data structure, so we can use it to store data like a bunch of customers. But the way a hash table stores data is different from how a list or an array stores data. And for this very reason, with a hash table, we can quickly look up an object no matter how many objects we have stored in the hash table. So whether we have 10 customers or 1 million customers, we can find a customer using only one comparison, and we represent it using the big O of 1. Now, technically, there is no comparison involved when we look up an object using a hash table, but you can think of it as a small computation step. Now, if you want to learn more about hash tables and how they work, take my Data Structures and Algorithms course. I've covered this topic in so much depth there. This is one of the subjects that is taught to computer science students. So if you're a self-taught developer, if you didn't attend a college or university, I highly encourage you to take this course because it comes up in coding interviews all the time. So this is all about hash tables. Now in Java, we have an interface called map, which represents a hash table. So in Java, we call them maps or hash maps. In C#, we call them dictionaries. In Python, we also call them dictionaries. In JavaScript, we call them objects. So the objects that we create in JavaScript, they're actually hash tables. For example, if we create a person object like this and give it a name, this is represented using a hash table under the hood. So different languages call it different things, but essentially it's the same thing. It's a hash table. In the next video, I'm going to show you how to use the map interface in Java.